All right, we're here on SanfordFlipMath with Ms. Benson today, and we're doing Springboard, Algebra 2, 11.3 Vertex Form, and we're just talking about how to change the function that is in standard form, like what we have here, into vertex form. So this is something that we've done in class already, so I'm just going to reiterate the concept to get some practice together. Okay, so when we're converting to vertex form, as long as we have it in standard form, you might see it as g of x, in this case, equals x squared minus 4x minus 1. You can also rewrite that. Don't let that confuse you, because you can write it as a y equals instead. And I'm just going to rewrite it that way for this purpose here, just because it'll make things a little bit easier for writing. Okay, so our first step, you can see highlighted on the right here, I have all the steps that we're going to follow to convert it to vertex form. So what we want to do first is move the constant to be with y, because we need to make something that we can complete the square with on that right-hand side with our variables. So I'm going to add 1 to both sides here. So we end up with y plus 1 equals x squared minus 4x. And we've got that first step checked off now. All right, so now we're looking at number 2. Factor out a if present. Well, here we're talking about the a that's part of standard form. We don't have an a besides 1. Well, we might as well just leave it as is instead of factoring out the 1, because that's not going to change anything. It's not going to change how anything looks. So the next step here, we've got that one checked off because we don't really need to do it. Step 3 is complete the square using the expression with a factored out. Well, we didn't factor out our a, so we're going to use this expression here and complete the square. So just a reminder, if you need to go back to the last video from 9.3, 9.1 and 9.3, that will have information about completing the square. So if you want to review that, you can do that. Here we're just going to do the process. So if you need some more steps with that, please go back to the other video. But so here on this side, we're going to add b over 2 squared, and this is referring to this b here. So we've got our negative 4 over 2 squared, so we've got negative 2 squared equals 4 here. So we're going to add 4 to this side. We got that for number 3. Now to the other side, we need to add the number needed to compensate. So in this case, we'll see in another example where we need to do something else. But in this case, we added 4 to this side. There's nothing else we're doing to that 4 on this side of the equation. All we're adding here is a 4. So in order to compensate, we're going to add it to this side as well. Okay, to make sure that those sides are equal and balanced all the time. Make sure that we keep an equal expressions on either side. Okay, so we end up with y plus 5 on this side, and then our x squared minus 4x plus 4. Okay, we've got our number 4 covered. Here's now for number 5, we need to factor. So again, with completing the square, what we're going to factor into on this right-hand side, because that's the side we're factoring, is what has our x squared term in it. We are going to end up with x plus something squared. That something here is always going to be b over 2, just as it is in completing the square. So in this case, our b over 2 was here, our negative 2. So we're having x plus negative 2 squared on that side when we factor. And that is equal to y plus 5 still. Okay, so we have that all covered. Let's see, let's just check. We got that step 5 done. Now for number 6, bring the constant back to be with the factored expression. Bring it back to the other side. So the constant that we moved over before was a 1, but this is the constant that we've now simplified that's on the side with the y. Well, we want a we want it to be y equals something factored plus or minus a constant. That's what we want it to look like. So in order to do that, we're going to subtract 5 on both sides. Okay, when we do that, we end up with y equals x minus 2 plus negative 2 up here is the same as x minus 2 down here. Okay, x minus 2 squared minus 5. And we now have it in this form, in vertex form, what we are calling vertex form. Well, and the book calls it, and everywhere else you see it, we'll call it vertex form. Okay, so now that we have vertex form, why do we call it vertex form? Well, let's go to that. So as you can see, this is what we just came up with. This is the vertex form that we just found. Okay, so now this looks like something that we can describe the transformations of. And if you need help if you want more information about transformations, if you want to go back to that, you can go back to video 4.3, or there's a series of 4.3 videos that you can go back to for more detailed information about transformations. But here, I'm just going to talk about what happens, and then we're going to focus on the vertex form again here. Okay, so in this equation, in this function, we're talking about the transformations that are happening. Now we can see we don't have anything on the outside in front, so there's no stretch or shrink. But we do have on the outside here, there's nothing happening here. Okay, so I'm just going to erase that arrow. Okay, on the outside, we also have a -5. Well, the outside affects our y's. Okay, so just a quick reminder here. Outside affects y direction. Okay, so since we have a -5 or a -5 on the other side, this is going to move our graph down 5. Okay, now on the inside, with our x, inside the parentheses, we have a -2. Well, inside is inverse again, so we have a -2, which means that we're moving our graph right 2. Okay, so our parent function is going to be our x squared. So parent is x squared, or y equals x squared, or x squared equals y, however you want to write it. Okay, so that graph is going to be moved down 5 and right 2 based on our function here, based on what's in vertex form. So if we're moving it right and down, we're not changing the stretch or shrink. Those two parts affect where the vertex is located. So those two numbers here, this here and this here, tell us where the vertex is located. So we move right 2. That means that our vertex is going to be our x value will be at 2, down 5. The y value for our vertex is -5. So the vertex for the graph is 2, -5. We're also talking about our axis of symmetry here. So axis of symmetry, if we have something, this is just a basic parabola. So the axis that passes through the vertex here, okay, that's a little bit off, but the axis that passes through the vertex is the axis of symmetry because it looks the same on this side, looks the same as this side. Okay, so our axis of symmetry passes through the vertex. It's a vertical line, which means the equation for the line is going to be an x equals equation. Okay, so we have our axis of symmetry is x equals, and in this case here, x equals 2. So our axis of symmetry is x equals 2. Okay, so now we're going to do the same process for another function that's in standard form. Okay, we're going to first convert it to vertex form, and then we're going to talk about transformations, where the vertex is located, and the axis of symmetry. So this one's a little bit more complicated. We see that it's in standard form once again, but our a is not equal to 1. So we're going to have one more step in here compared to the other one. Okay, we can still follow our basic steps. I'm going to again write it as y equals -3x squared plus 6x plus 9, just because the y equals makes it a little bit easier to write, but that's all. The function f of x, the function of x, is the same as y in this case. So we're going to then do our first step, subtract 9 from both sides, moving that constant over, so we'll have something to complete the square with. We'll have an expression on that right-hand side of our equation to complete the square with. Now the second one is we need to factor out a if it's present. Well, here we do have an a, right? The a is part of ax squared plus bx plus c. So we're going to have, when we factor that out, that means we want to take this out of each term here, so that when we multiply it back through, we get the same thing that we have right here. Okay, so what I mean by that is if we pull -3 out of, we factor it out of that expression, we get a -3. -3 times what will give me a -3x squared? X squared. Okay, now -3 times what is going to give me 6x? That's going to be a -2x, right? Because I have my -2x times -3 gives me plus 6x. Okay, so now I've factored out my -3 from that, factored out my a, or my -3 from that side. Okay, now I need to complete the square with the expression where a is factored out. So I'm going to complete the square inside this parentheses, which means I'm using only these numbers within here. So I'm kind of treating this as an isolated situation just for the moment. Okay, so here we have my b over 2 squared is what I'm adding. So I've got -2 over 2 squared, which gives me -1 squared equals 1. So I'm adding 1 here. Now I need to compensate with another number on the other side. Okay, so here I added, so inside the parentheses, I added my 1. But when I add 1 inside here, what's also happening to that 1 is I've already factored out a 3. So if I were to re-multiply this side, re-multiply the -3 through, I would have -3 times 1, which is -3. Okay, so since that's the case, I need to add -3 to this side, or subtract 3 from this side, in order to compensate for the 1 I added over here. Okay, and that's because I want to make sure they balance. So what I'm really doing is adding a -3 to the side when I put the 1 in the parentheses. Okay, so now I need to simplify this side. We've got y minus 12 equals -3 times x squared minus 2x plus 1. Okay, now I need to factor that stuff in parentheses, factor what I have my x squared with, factor my x squared expression, my quadratic expression there. So we're going to, just like completing the square, we've got x plus something squared. That something is going to be b over 2. We already know that b over 2 from up here is -1. So I'm going to add -1 inside the parentheses there to simplify, to factor. And now I just have that bringing the constant over to the other side. That's all I have left to do to make it look like vertex form. Okay, so I end up with y equals -3 times x, the quantity of x minus 1 squared, plus 12. Okay, so here we've got, again, this is in vertex. This is vertex form. And we can use this. This is the type of form that we can use to figure out transformations and where our parent function of y equals x is going. Okay. Okay, or y equals x squared, I'm sorry. The parent is y equals x squared here. Okay, so again, you can see that this matches what we had over there, or what we just found, what we just put in vertex form. Okay, so what we're doing now is we need to describe the transformations, identify the vertex, and the axis of symmetry. Okay, so let's start with describing the transformations. Well, this here, that's a -3 on the outside, so I know outside affects the y's. So the negative part means that it reflects over the x-axis, because that's in the y direction. It's going to flip upside down. Okay, so reflects over the x-axis and a vertical stretch of 3. Okay, so now I'm going to pay attention to the other stuff that's on the outside of that parentheses to see what else is being affected in the y direction. Okay, we've got a plus 12, so we go up 12, but inside the parentheses I have something else. Here we've got minus 1 inside. Inside is inverse, so I'm going right 1. Okay, so those are all the transformations. Now to identify the vertex, we already figured out last time that these two numbers are what's affecting the vertex, right? So does that negative 3 have an effect? So when we stretch it, when we stretch a function, it doesn't actually change the vertex. It doesn't change that origin point on the graph. So all we need to look at still, even with that negative 3 out in front, is the negative 1 and plus 12 from before. We know the inside is inverse, so we have our vertex is going to be at 1, 12, right? So we go right 1, up 12, right 1, up 12, and then our axis of symmetry, once again, is going to be, we need to look at that number in order to figure out what that axis of symmetry is going to be. So the axis of symmetry for this function is x equals 1. Okay, so this is just an overview of changing a quadratic equation in standard form to vertex form, and then the transformations that result that give us the vertex and the axis of symmetry of the function, of a graph of the function, I should say. And if you need some help with some further transformations, refer back to 4.3 SanfordFlipMath. And that's all for now. We'll talk to you later. Bye.